This is a practice exercise from page 167 of the textbook. We're looking at a change in energy for a process where we have a system absorbing 140 joules of heat from the surroundings and doing 85 joules of work on the surroundings. So the first thing we want to do is make sure we understand what the difference is between the system and the surroundings. So when we talk about the system, typically that's the chemical reaction that we're talking about. So we have something smaller that we refer to as the system, and around the system is what we refer to as the surroundings. When we do calculations with energy, it's really important that we understand the direction that this energy is moving. So let's take a look at the two different types of energy we have. The first thing we have is we've got 140 joules of heat energy. For us, heat is going to be abbreviated with the letter Q. So it's a variable we use for heat, that's Q. And in this case, they're telling us that the system is absorbing that heat. So if the system is absorbing the heat, that means the heat is going from the surroundings into the system. So the Q is entering the system, and if it's entering the system, that's going to mean a positive sign because the system is gaining heat, and we always think of things from the point of view of this system. Next thing we know is that it is doing 85 joules of work on the surroundings. Work is going to be abbreviated with the letter W, and in this case it is doing work. So doing work on the surroundings means that W is going from the system into the surroundings, and that's going to give us a negative sign for work because the system is doing work on the surroundings. So when we ultimately calculate the change in energy for a system, then change in energy is always going to be equal to Q plus W. In this case, we know that our Q is positive, so 140 joules, and we know that our work is negative, so negative 85 joules. When you do that math, you should come up with an answer of positive 55 joules. So that's the total change in energy for the system, because we've got 140 joules of heat going in and 85 joules of work going out. So again, every time you do these problems, please make sure you understand what the system is, what the surroundings are, and the appropriate sign conventions for when heat enters and leaves, and when work is done either to the system or to the surroundings.